So it's going to tell you some main stuff to study for it, unless you don't want to know that. So page 11 of your notebook. It's going to come in two parts. A calculator section and a non-calculator section. Typically, calculator section problems are harder because you've got more tools available. So, stuff to look for on your calculator section. Analyze graph of an equation. Or just analyze the equation and find out what you can about the graph. Now, when I say analyze, there's a lot of things we can do with it. So we can do domain range. We can do end behavior. Let's see, continuity. Extrema. Symmetry. Intercept. Where it's increasing, decreasing, constant. And maybe you were saying, what is the parent graph? What's the shift? So all sorts of little pieces of information could be asked for. And my guess is for the calculator section there can be probably one or two problems that are like this that are going to ask you a whole bunch of information about it. About a single problem or a single equation. Figure out if you can do it. Make sure you know how to use your calculator to find the steps that you need the calculator for. Because this is assuming you have a scientific or graphing calculator and know how to use it to find things like maximum and minimum. Any questions about the list there? Symmetry. So is it x-axis symmetry, y-axis symmetry, origin symmetry, all of that? Intercept. X-intercept, y-intercept. Is there any increasing, decreasing constant? Where is the constant increasing? For what range? Where is it decreasing? Where is it constant? All that. For continuity, what types of discontinuities do we have? Infinite discontinuities, jump discontinuities, and removable discontinuities, or points. The removal and point are the same. So make sure you know which is which. So the next thing on my list, composition of functions. This means something like s plus, or s minus, or s divided by, or s times, or s of g of x. So I put them all in there. That's bad notation, but you get the idea of what I'm asking about, right? Or maybe of 3, so evaluating. So if I give you f and g, you should be able to do any of these things with it. Or if I just give you f, you should be able to do f plus f of x, or f minus f of x. F of f of f of x. All of that. Or if I use the number 3, you should be able to use 3 or 15 or pi into there just as well. And I have finding inverses. Here are the 4 steps. Yes, that's it. What the key step is swapping. You had substitute, swap, solve, and substitute. So that's the type of thing you're going to expect to see on the calculator section. Non-calculator. It has that whole list of parent functions that you need to know. You need to be able to graph them without a calculator, and without having to take the time to plug in a bunch of numbers. What do you do, about 12, 13, 10, however many graphs, you should be able to do any of them fairly rapidly. If you run out of time, you're going to run out of time. Okay? And transformation. So if I give you the parent graph and give you another equation, that's a transformation, but you should be able to describe what the transformation is in proper terminology. In other words, don't try flipping them. You can say flipping or inverting or several things, but as long as you say horizontal invert horizontally or something like that, or flip horizontally, make sure you when you're flipping horizontally or sideways. Or stretch, I don't mind if you do stretch or compression or expand, contract, lots of terms you can use, but as long as you're saying in the right direction. Let's see. Graphing of these. So maybe I'll give you a equation that uses a parent function as a transformation and expect you to give the graphic. And all this should get to be done fairly quickly. Meaning if it takes you more than a minute to graph any of them, you probably need to spend a bit more time practicing or studying it. Because most of them say if we did this, y equals square root x minus 4, everybody knows the square root graph looks like, right? And what does minus 4 do to it? And so we can easily do a graph. 1, 2, 3, 4. Something like that. So, enough that it's quite accurate, but say if the point, we know we go through 1, 1, and if you made it 1, 1.1 or 1, 1.5, 1.5 is a bit off, but fairly accurate. But I mean, it doesn't have to be, like that was probably a bit further off than I would want. But, for example, if you did y equals 1 over x, what are 2 points you know it goes through? 1, 1 and negative 1, negative 1. And make sure and what does it look like? You got your asymptote, right? So if you show you've got asymptotes and it's going through 1, 1 and negative 1, negative 1, and you got your asymptotes, then you're good. You don't have to go, okay, plug 2, I have to plug in 2, 1/2, 3, 1/3, and so on. Get the key point.
You just have to show you understand.
Yeah. So you know the graph and understand what's being done to it. Next one I have here is end behavior. So in other words, I should be able to give you a function, and without using your calculator, you should be able to describe what the end behavior of it is. So if anybody want details on any of these, or have specific questions about this, because that's what I'm basing stuff on. Or if one of these types of problems you want to do, or questions in your homework. Yeah, I'm sorry.